Dear students, in the previous video we discussed about the definition of push-down automata for context-free language. Now we are going to discuss about how to implement PDA, that is called push-down automata for context-free language through some problems. What are the steps involved in solving the PDA problem? The moment they gave the problem, first analyze the particular language like A power n, B power n or whatever may be, and how to implement the same in the stack and try to bring the concept. In step 2, whatever you implement in the stack, try to bring the transition equation for that. In step 3, using the transition equation, draw the state diagram. In this major work is bringing the concept, that is called step 1. Now I am just starting the problem, A power n, B power n problem. That is, how many number of A's, that many number of B's. How to construct the same using PDA. Now let us analyze. The analyzing part is important. I have taken 3 A's and 3 B's. That is, any number of A's followed by same number of B's. Which means, how you are going to take B's? Are you going to keep the count of A's? No. How many A's are there? That many B's are there. If you could put these A's in a stack, if A's is completed, empty, then B also should be empty. Now let us put all A's in the stack and make it the stack filled with only A's. As per my example, 3 A's, which means I am going to use 3 times. If input is A and the top of the stack is Z0, then push A here. I pushed. Now if the input is A and top of the stack is A, again push A. If input is A and top of the stack is A, again push A. Now who is the next input? B. Now just carefully see here. Between this step and this step, top is A. Between this step and this step, top is A. Between this and next step is top is A. Always top of the stack is A many times. But the first time top of the stack is Z0. That is one time. Okay, remember, based on this we are going to do the states also. Now, how many number of A's come doesn't matter. You are not going to count. Keep on put in the stack. Now, B is coming. Then, how to take the B? If all A's are over, B should be over. Now, how many A's here? 3. How many B's will come? 3. This is the example. Now, what I am going to do, from here to here you are changing the state because A is going to become B. If input is B, just pop and make sure that Z0 is not there. If Z0 is coming, which means A is over, B also should over. I did pop. Again, input is B, just to do pop. Again, input is B, just to do pop. If I do, the result will be this much. Now you carefully see, who is the top of the stack? Z0. Is it any more input is coming? No. Which means all B's over, at the same time all A's over. Conclusion is number of A's equal to number of B's. Now this is a state. You are changing the state to Q1 by bringing A. Again you are changing the state to Q2 by emptying the A. Now more detail about that we will discuss later. How to calculate the transition? Very careful. What I did, put all the A's in the stack, and when you read all the B, all A should be popped. That is, it become empty. Now with this particular diagram, let us bring the transition function. Input is A, top of the stack is Z0, push A. Now the transition representation is this much. You are in the beginning value Q0. If input is A and top of the stack is Z0, then push A above Z0. Push A above Z0. The state Q0 is retained the same. Now at the same time, one more A is coming. When one more A is coming, you should put A above that particular A. That is what? If input is A here, top of the stack is A here, push A above this A. That is what I am doing here. The state doesn't change because only A is coming. When B is coming, state will change. When B is empty, state will change. Again I am repeating. If A is coming, one state. If A become B, another state. If B is empty, another state. Now y dot dot dot, many A's are there, dot dot dot. Next B is coming, okay, pending. Next B is coming, okay. Now what I should do? If B is there, pop A, that is number of A's will be reduced, okay. Now when B is there, if the top of the stack is A, pop. Now you see, once B is coming, you are changing the state. That is what Q0 become Q1. Again next time, many B's are going to come. Many times you are going to repeatedly do pop. So maintain the same state Q1. Dot dot dot. Now last, when nothing is there, when the top of the stack is Z0, story over. So nothing is there, epsilon. Top of the stack is Z0. Just pop means it is story is over. That when it is B is empty, state is changing. So this group is for A input, this group is for B input, this group is for no input. This is the major work we are going to do. Now I am going to draw state diagram. What is the state diagram? Input is Q0, I made. Q0 become Q0, obviously self loop. Q0 become Q0, self loop, I made. A, comma Z0 slash AZ0. A, comma A slash AA. That's the meaning. Next B is coming. Q0 is going to change to Q1. Q0 is changed to Q1. B, comma A slash epsilon, pop. Q1 is retained is Q1, self loop. What and all I will get? B, comma A slash epsilon. Next last stage is going to Q2, epsilon slash comma Z0 slash epsilon. Now the whole story over. The story is accepted, PDA accepted. Now step 1, analyzing the language. Step 2, transition function. Step 3, state diagram. Now these are all the transition equation. Now I am going to bring machine equation M with 7 tuples. Now before that, this dot 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 I removed, just I made it the statement called delta. Now the machine equation is ready. Who is Q? Q is nothing but Q0, Q1, Q2. Who is sigma? A, B. That's all. Who is gamma? Who is in the stack? A and Z0. B is not there in the stack. Next, who is delta? This fellow is the delta. Who is Q0? Initial state or start net. Who is Z0? Initial symbol on the stack called pointer. Who is F? Final state is Q2. Let us see one more problem, that is WW power R using PDA. How let us construct the PDA? That is the word and reverser of the word. Now if you take that particular string 0, 1, 1, middle level, 1, 1, 0, the reverse. Now if you stand in the middle, this one counterpart is this one. This one counterpart is this one. This 0 counterpart is this 0, which means whatever the letter comes, same letter. If it is A, Q, Q, 0, 0, 1, 1. There is no rule that first 0 next 1. It depends on how the problem is. Now what I am doing, push all the symbols to the stack up to the midpoint. Now 0 is coming, push here. 1 is coming, push here. Again one more 1 is coming, push here. Now technically we reached the middle point. Once the middle point is reached, next story depends on what term it is. 1, 1. If 1 is coming, if the top is also 1, accepted. If 1 is coming, if it is 0, rejected. Okay, that we won't mention, only accepted state. If it is not satisfying, it is rejected. 1, 1, pop. What is that I am going to do? Another 1, 1, pop. Next 0, 0, pop. Once I complete this, no more input epsilon. Top of the stack is Z0. The state is changed. As usual, when all the terms are giving input, it is Q0. Once middle level comes, when you pop, it is Q1. Once the stack is empty, it is Q2. Let us see step 2 called a transition function. What that I am going to do? Delta Q0, 0 is the input. Top of the stack is Z0. What that I am going to do? delta Q naught, 0 is the input, top of the stack is Z naught, push 0 above Z naught. That's what I am doing. Q naught is Q naught. Again, Q naught, because all this is stage 1, Q naught, when 1 is the input, top of the stack is Z naught. Again, push 1 over Z naught. Remember, my dear, this 1 is not this one. This 1 is not this one. That 1 is says starting can be 0 also, 1 also. That is the first letter, because there is no rule that 0 should be the first letter. It can be 1 also. So hereafter, what are the rules I say for 0, I will do for 1 also. This story is only for the first element. Now I am going for the remaining elements. In remaining elements, if 1 is coming, what you should do? We'll show that both. If 1 is coming, and if the top value is 0, or if the top value is 1, it depends on the previous value. Okay. If 1 is coming, if top value is 0, or top value is 1, then push 1 above 0. Actually, this is satisfying here. 1 is coming, top is 0. But it is also should satisfy here in the next stage. If 0 is coming, if the top value is 0, push 0 over 0. If 0 is coming, if the top value is 1, push 0 above 1. Okay, this all 4 stories is 4 combination. Input is 0, top value 0 or 1. Input is 1, top value is 0 or 1. This is for all other inputs. Now the state is changing. The state is going to another state called Q1 at the mid level. Q0 to Q1 I am going. If 0 is coming and if the top is 0, then only pop. If 1 is coming, if the top is 1, then only pop. If it is controversy, you should not pop because it is not satisfying the palindrome concept. Q0 to Q1. After that, many letters are coming. So Q1 it will maintain. After crossing the point, the same equation I will repeat. Q1 only will come because the state remains the same. Next, continue. Now let us go to the last one. If the input is empty epsilon and if the top is Z0, then just put. We are ready with the transition function and we are going for the state diagram. Starting is Q0. Q0 to Q0 self loop I am having. Q0 to Q0 self loop. Total I should have 6 different values. 0, Z0 slash 0 Z0. 1, Z0 slash 1 Z0. Now all the stories 1 I will show. 0, 0 slash 0 0. Like that 4 terms are there. 1, 2, 3, 4. Ready. Next Q0 to Q1. Q0 to Q1. What you should do? These two equations 0, 0 slash epsilon. 1, 1 slash epsilon. Next Q1 to Q1. 2 more equations self loop. Last Q1 to Q2. Epsilon, Z0 slash epsilon. The stage is accepted. Now this is the state diagram. Using this set of transition equations, we are going to do machine equations. That is your M. Q is nothing but Q0, Q1, Q2. Sigma is nothing but 0, 1. Gamma is nothing but 0, 1, Z0. Delta is nothing but all these stories. Q0 is nothing but initial value, Z is top of the stack, F is nothing but final state which is Q2. With this, I would like to complete PDA problem. Better pause the video and rewind it and carefully analyze. And make sure that Q0, Q1, Q2 are the most critical part. The state changes when the transition changes. When A is coming Q0, when A become B, Q0 become Q1. When B is completed, Q1 become Q2. In the same way, when the first set of values are coming Q0, when middle point is reaching Q1, when all second set is completed, it goes to Q1, Q2. So remember, first set, second set. First set is Q0. First set to second set transition is Q1. When second set is completed, it is Q2. Thank you.